Hello student, I am Deepak Gule, senior lecturer in SPM Polytechnic. I am teaching you. The course is Applied Electronics and the course code is 22329. Today we will discuss the working of the single stage common emitter amplifier. As shown in this above figure, only a single transistor is not used for the amplification purpose. We are uses the another supporting component for the amplification of this transistor, that is resistor and capacitor. By the combination of all these resistor, capacitor and this transistor, we are called it is a single stage common emitter amplifier circuit. आता हे कंप्लीट सर्किट आपण ॲम्प्लिफिकेशनसाठी यूज करत असतो. आता आपण हे ॲम्प्लिफायर म्हणून कशा प्रकारे वापरले जाते ते पाहूया. जे सिग्नल आपल्याला ॲम्प्लिफाय करायचे आहेत, दॅट सिग्नल वी आर कॉल्ड इनपुट सिग्नल or this is the weak signal. This weak signal we are applied between the base and emitter terminal of the transistor as shown in figure of the left side, and amplified output, that is strong signal, we are taken across the collector terminal and emitter terminal of the transistor, or we can get this amplified output across the load resistor RC. The total amplified instantaneous output voltage, that is VCE, is given by the above formula, that is VCE is equal to VCC minus IC into RC. When we are applied a positive half cycle of the signal at the base and emitter junction, the base current of the transistor is increases. That gives the result to increase the collector current due to the transistor action. Hence, voltage across RC will increases. हे कशामुळे होतं? तर आपल्याला फॉर्म्युला ऑफ व्होल्टेज हे माहीत आहे. RC इज इक्वल टू IC इंटू RC. म्हणजेच IC जर इन्क्रीज झाला तर ॲटोमॅटिकली द व्होल्टेज अक्रॉस द RC विल बी इन्क्रीजेस. Whatever the input voltage VCC we are applied, that voltage is constant. Therefore, output voltage across the collector terminal and emitter terminal, that is VCE, is start decreases as per given above equation of the VCE. In another words, we can say that the signal voltage of the input is increases in positive half cycle, the output voltage is increasing in the negative direction, that is we are getting the output is 180 degree out of phase with the input. From this explanation, it is clear that in a common emitter amplifier, the positive half cycle of the signal appears as in the amplified negative half cycle at the output terminal, and when we are applied a negative half cycle to the input of this amplifier circuit, we are getting the positive half cycle at the output. Now we will see the next bit is frequency response of single stage CE amplifier. Frequency response means what? That is the find the relationship between input frequency and voltage gain of the given amplifier by keeping input voltage is constant throughout. म्हणजेच ज्या वेळेस आपण सिंगल स्टेज ॲम्प्लिफायर सर्किटचं इनपुट कॉन्स्टंट ठेवत असतो आणि त्याला इनपुट सिग्नल जे काही आपण देणार आहे त्याची फ्रिक्वेन्सी जर आपण चेंज करत राहिलो तर प्रत्येक फ्रिक्वेन्सीच्या वेळेस आपल्याला वेगवेगळं व्होल्टेज गेन्स मिळत असतात आणि यांच्यामधलं जे काही रिलेशन आहे म्हणजेच व्होल्टेज गेन आणि फ्रिक्वेन्सी रिस्पॉन्स त्यालाच आपण फ्रिक्वेन्सी रिस्पॉन्स कर्व असे म्हणत असतो. आपल्याला समोरील फिगरमध्ये दिसत असेल की एक्स ॲक्सिसवरती फ्रिक्वेन्सी दिलेली आहे आणि वाय ॲक्सिसवरती व्होल्टेज गेन दिलेला आहे. व्होल्टेज गेन आपण dB या युनिटमध्ये मेजर करत असतो तर फ्रिक्वेन्सी हर्ट्समध्ये मेजर करत असतो. आपल्याला समोरील फिगरमध्ये दिसत असेल की हा जो फ्रिक्वेन्सी रिस्पॉन्स कर्व आहे तो 3 पार्टमध्ये डिवाईड केलेला आहे. पहिला जो आहे तो म्हणजे लो फ्रिक्वेन्सी, दुसरा जो आहे तो म्हणजे मीडियम फ्रिक्वेन्सी आणि तिसरा जो पार्ट आहे तो हाय फ्रिक्वेन्सी. That is, as shown in above figure, it is clear that voltage gain is drop off at low frequency, that is below 50 Hz, and high frequency, that is above 20 kHz frequencies, whereas it is uniform or constant over the mid frequency range, that is from 50 Hz to 20 kHz, and this mid frequency we are called it is the audio frequency range. Hence we can say that this single stage common emitter amplifier can be known as audio voltage amplifier. So let us start to discuss regarding given frequency response. Now we will discuss at the low frequency, that is below 50 Hz, why the voltage gain is fall off. The first reason is CC, that is coupling capacitor. The reactance of the capacitor is given by Xc is equal to 1 divided by omega C, that is omega is 2 pi f. The reactance of the coupling capacitor when the input frequency is less, that time it gives the high reactance, and due to that very small part of input signal is passes from one stage to the next stage, that gives automatically output voltage or output voltage gain is less. The second reason is emitter capacitor. The input signal is at the low frequency. Due to that, this capacitor CE can't shunt the emitter resistance effectively because of its large reactance at low frequencies. The third reason is input capacitor Cin. The reactance of the Cin capacitor is also very large at the low frequencies. Hence, input signal is not properly coupled to the base of the transistor. Next is the frequency response at the high frequency. That is, the frequency is above the 20 kHz. When the input signal of a high frequency, that is above the 20 kHz frequency, the reactance of this coupling capacitor Cc becomes very small and it behaves as a short circuit. This increases the loading effect of next stage and serves to reduce the voltage gain. However, at high frequency, capacitive reactance of base emitter junction is low, which increases the base current. This reduces the current amplification factor beta. Due to these two main reasons, the voltage gain is dropped at the high frequencies. At the mid frequency, that is from 50 Hz to the 20 kHz. If the input signal of frequency is in this range, the voltage gain is become constant because reactance of coupling capacitor Cc and Ce capacitor is moderate. Due to this, there is no loading effect. Also, Ce act as a perfect shunt to Re resistor. Thank you student for watching this video. If you have any doubt about this, please WhatsApp me.